Good afternoon, everybody, and welcome to this Brainwaves webinar on teenagers and sleep. Thank you very much for joining us. My name is Tracy. I'm the Education Content Manager here at Brainwaves, and I'm going to be your host for this afternoon. So I'd like to start by welcoming our very special guest for today, Professor Russell Foster. Russell is a professor and world-leading expert on circadian neuroscience. He is the head of the Nuffield Laboratory of Ophthalmology and the Sleep and Circadian Neuroscience Institute at Oxford University. He is also author of this incredible book called Lifetime, The New Science of the Body Clock and How It Can Revolutionize Your Sleep and Health. Thank you very much for joining us today, Russell. Hi.
Hello, Tracy. Really lovely to join you. Thank you.
And also here to talk to us today is Julian Turner. Julian is Director of Education here at Brainwaves and former Chair of Governors at the LeSwap Consortium of Sixth Form Colleges in North London. Good afternoon, Julian.
Good afternoon. Good afternoon, everyone.
So the main reason we're here today is because we know how important sleep is to teenagers in terms of their mental health and well-being. And we believe it's very important to try and share and support that information with students about sleep education. So at Brainwaves here, we've actually developed some lessons on mental health and on specifically sleep. And that's why we're doing the webinar today. And I'm going to tell you a little bit more about those lessons at the end of the webinar. But for this format for today, it's very straightforward. We're here for 45 minutes until 5 o'clock. We've got a number of questions that a number of you have already submitted. Thank you so much for those that we're going to be asking Professor Foster. And if we have time at the end, we may be able to take some more questions. We'll see how much we can get through. Please feel free to join in the chat today. You can do that by clicking on the speech bubble icon and typing in your comments. The only thing you need to remember is to select everyone when sharing so we can all see what you've said. Right, now we're just going to start off with a quick question for you to take part in via an interactive poll. So hopefully that should be coming up on your screen now. Let's see if that seems to be working. And the question is, how many hours of sleep do you think a teenager needs on average? So the options are 7 to 8 hours, 8 to 10, 9 to 11, or 10 to 12. And I'm just going to give you a few moments just to ponder on that question. And we're also going to talk to Professor Foster about some of the variables around this question. But I think the majority of you, well, about half, I'm just going to end that now. So apologies if you didn't have time to vote. Hopefully you should be able to see those, but just over half of you came up with the right answer, which is on average about 8 to 10 hours. But Russell, that does depend on a number of variables and individual circumstances. Is that correct?
That's absolutely right, Tracy. And I think that we shouldn't be too prescriptive about this because it can generate anxiety. As we were chatting beforehand, I've had people come up to me and say, I don't get 8 hours of sleep. Am I going to die? And I sort of say, well, yes, I can guarantee you're going to die, but it may not because of the sleep duration. I mean, sleep is like shoe size. It would be crazy to make everybody wear the same shoe size. And so the range, as discussed by the National Sleep Foundation, between the 18 to 64 age group, and this is a very big age group, can be as short as 6 hours, and it can go up to 11 hours or even more. And the key thing for each of us is to define how much sleep that we need and then try and stick to it. And so the points are, do you feel as though you're able to perform optimally during the day? Do you oversleep extensively on free days, particularly at weekends and on holiday? Are you dependent upon an alarm clock or another person to get you out of bed? Does it take you a long time to wake up? Do you have sleep inertia? Do you feel groggy? Do you feel sleepy, irritable, fatigued when you are awake? Do you crave a nap? And we should talk about napping, I think, later on. Do you feel that your behavior is overly impulsive? Are you doing stupid and unreflective things? Are you craving caffeinated and sugar-rich drinks? And finally, listen to your family, friends, colleagues about showing altered behaviors. You know, are they saying you seem a bit irritable? I mean, you know, you don't seem to be as empathetic as you were. You're doing, again, disinhibited things. So it's about working out what works for us.
Interesting. Gillian, any thoughts there?
Yeah, I mean, I am the parent of teenage children, so everything that you're saying resonates very, very much. And I think one of the things that we can do actually is just to help young people to increase their self-awareness about what their own sleep needs are. And actually, one of my brood has really learned that over the last couple of years, is extremely aware of what her sleep needs are and how to manage that, whereas in another example, not so much. But I think that could be really helpful.
Yeah, I agree.
Perfect. So can we start that off then, Russell, by just having a quick look at how sleep does change for teenagers and how it's different to what adults experience, or maybe from their sleep patterns as a child as they progress into being a teenager?
Yeah, from the age of about 10, there's a tendency to want to go to bed later and later. And this peaks in young males at around about 21 and a half, young females about 19 and a half, 20. So women tend to peak earlier in their lateness than men. And men tend to be on average later than women. And from this point in the sort of early 20s, there's a tendency then to want to go to bed earlier and earlier. And that's a slow move. So by the time you're in your late 50s and early 60s, you're getting up and going to bed at about the time you got up and went to bed at the age of 10. And so this tracks almost perfectly the circulating levels of the sex steroids, testosterone in males, estrogen and progesterone in females. And so, and of course, we know that women tend to peak earlier in terms of puberty than men. And so it follows that line perfectly. So there is that developmental effect. I think it's also worth pointing out that sleep timing and sleep duration can depend upon one's genetics. And we now have very clear evidence, beautiful data showing that subtle changes, some polymorphisms in the genes that make up the biological clock can make you more of a morning person or more of an evening person. And then finally, when you see light is incredibly important. And that's the one factor we have some control over. So morning light advances the clock, makes you get up earlier and go to bed earlier, whereas evening light delays the clock, makes you go to bed later and get up later. And we did a study actually on university students all around the world a few years ago and showed a beautiful correlation with the later the chronotype, the morningness versus eveningness, the later the chronotype was perfectly correlated with reduced amounts of morning light, which would advance the clock, but large amounts of evening light, which would delay the clock. And so that's I think a really important issue. So if you are a late type and you've got to get up earlier, then one way to deal with it is to set the alarm and then get morning light. I go outside or from a light box, and that will help you advance the clock and make it easier. And in the same way, of course, as many of us want to oversleep at the weekend, what's happening is you miss that morning light, but you get the light later in the day, which delays the clock. So when you get to Monday, you're actually shifted and would want to get up later. So, it's really important to try and stabilize your light exposure and your sleep-wake cycle.
Interesting. You mentioned that teenagers want to go to sleep later. Is there anything what's causing that in their makeup?
I mean, it's essentially the way that the system is structured, and so we know that for example, the effects of light. I mean, it's actually delaying the clock. Dusk light is actually shifting the clock to a later time, and morning light the reverse. I think what's fascinating though is that on average, and again, I think it's really important that we stress these are averages. Somebody in their late teens, early 20s will want to get up and go to bed 2 hours later than somebody in their late 50s, early 20s. So, asking a teenager to get up at 7 o'clock in the morning is like asking a 55-year-old to get up at 5 o'clock in the morning. So there's a definite biological basis for going to bed later and wanting to get up later. And it's important that we understand that. And that we can then use, as we'll discuss later, some ways of dealing with that to some extent.
There's some great questions coming in from the chat literally as we're chatting, so I'm going to try and address those. Firstly, if the sun comes up early, will teenagers wake up earlier than when the sun comes up later?
We all will. Yeah, I mean, and there's two things. I mean, there's when we were all agricultural workers and we got, symmetrical exposure to the light dark cycle. In fact, our sleep-wake cycle and our timing of sleep-wake expanded and contracted over the seasons. Now we're detached to some extent from the natural light dark cycle. So we don't see it as much, but absolutely. And so there's the effects of light on the clock, but also the acute effects of light on alertness. So we can actually detect the light coming in through our sort of through our eyes and actually through our eyelids. And so that will also help wake us up. So if you're waking up, it's getting light at 5 o'clock in the morning or so at the moment, 5, 6, then, and that's too early, then blackout blinds can be very useful under those circumstances.
Does that mean that we generally sleep better in the winter then? Yeah, are there, how does this work with seasonal changes?
Yeah. Well, that's difficult to answer. I think it'll again depend upon the individual. Certainly, the sleep patterns tend to expand during the winter months compared to the summer months. Whether that's bad or not isn't clear. We know it changes, but we've been experiencing this dynamic change in the light dark cycle and our sleep patterns, for thousands, if not millions of years. So I wouldn't want to sort of say it's bad or good, but it's certainly, it does change. For some people, it will have an impact. I mean, if they're waking up really early, then they'll want to go to bed much earlier. And it might be tricky because if it's still light, and they don't have blackout curtains, it's going to be more difficult to get off to sleep.
And so, I guess that interacts in some way with seasonal affective disorder as well, where some people have a sort of that which seemed almost might go the other way, where you've got some people experience better mental health outcomes in the summer months, even though sleep may be more disrupted.
Yeah, and in fact, in the same way that those seasonal affective disorder with shortening winter days, expanding nights, you can also get it some elements of SAD during the summer as well. But light is very interesting. It has a fascinating impact upon levels of depression generally, and some studies who've compared light, and that's 30 minutes of light at 10,000 lux from a light box, so the sort of thing you'd see outside in the morning, versus Prozac. And light was much more effective than Prozac in reducing levels of non-seasonal depression. So, light is increasingly thought of as a therapeutic intervention.
Couple of questions from Anthony Brennan in the meeting, who one of which I think maybe we should come back to later, which is, do you think that if there's a case there for moving exams to winter months as teens get more sleep in preparation of those exams? But I don't need to answer that now, because we're going to come back to what we do about this. What we do about this later on. You can build that in. But the other question was going back to what you were saying about sleep and the sex hormones. Is that correlation or causality? Anthony asks.
So in humans, it's correlation. But what we've got from animal studies, some very nice studies showing, well, actually, we've got in both humans and mouse studies that there are estrogen and testosterone receptors in the master clock. So we know that there's a way in which those signals could have an impact. But what's so fascinating is that in mice, there's a 4-day estrus cycle. And what happens is that you know exactly what stage of the estrous cycle the mouse is in, because it will either advance or delay wheel running activity. So you can correlate it perfectly with the phase of the 4-day estrous cycle. And of course, there are studies in human females where sleep will change across the menstrual cycle. It's not so clear, but it's certainly been documented in some cases. So yeah, I think there's enough to say that there's some mechanistic, there's a mechanistic basis for it. As I say, there are receptors. We know that from animal studies, you can change timing by either giving a sort of sex hormones or the natural changes in estrogen and progesterone in female mice will change activity onset.
Thank you, Russell. We'll just slightly change focus now and just think about the lack of impact, the impact of lack of sleep for teenagers and how that might potentially have an impact on their academic achievement, on their mental health, on their well-being. What sort of statistics are you seeing, or, how is sleep being affected but for teenagers in this respect?
I think it's a really, really important issue. And I think we can think of the impacts of sleep loss on emotional responsive, cognitive responses, and sort of overall physiology. If we think about our emotional responses, and this is data which is and if you want I should say, in Lifetime there are 920 references. I now probably mean I've lost all sales, but I mean the important thing for me was making available the original studies so that you can look it up and validate these statements. So in terms of emotional responses, fluctuations in mood, increased irritability, increased anxiety, loss of empathy. I think this is wonderful. You know, you actually don't pick up the sort of those social signals and respond to them in the same way. Frustration, risk-taking, and impulsivity, doing these stupid and unreflective things that you wouldn't normally do if you had a full, a fully rested brain. Some beautiful data from Jan Bourne's group, who's coming to Oxford actually next year to give a talk. So we're going to make it a public talk, so people are interested. He showed that the tired brain has a negative salience. And what that means is that it remembers negative experiences, but forgets some of the positive experiences, which I think is just phenomenal. So the tired brain, the whole world view is biased towards negative. There's a greater tendency to use caffeine as a stimulant and other sedatives, and we can touch on those. But so for example, antihistamines that cross the blood-brain barrier can be used, and in fact I was told about Phenergan, which you can buy over the counter, which is an antihistamine. It passes the blood-brain barrier. And I thought, well, I'll try it, as you do. I'll see what impact it has. And boy, I took it on a Friday and I was wiped out for half of the Saturday. So some really quite potent sedatives, let alone alcohol and stealing parental alcohol, which is really bad for a whole raft of reasons. And of course, that can blend into illegal drug use. So that was sort of some emotional responses. Cognitive responses, well, overall, your ability to process information is reduced. Your ability to multitask, and what I mean by that is that, we're bombarded with information, and it's extracting the relevant bits for you to respond appropriately that falls apart when the brain is tired. Memory consolidation goes, the processing of information, and some wonderful studies have shown that a night of sleep can enormously help your ability to solve problems. There's a wonderful study done, which was a problem-solving task, and it was introduced to one group, and they had to become familiar with the task in the morning and then perform it that afternoon. And about 20% of the group solved the problem. The next group were familiarized with the task in the morning, but then performed it the following afternoon, but didn't have any sleep or had minimal sleep. And about 20% of the group solve the problem. So nice control of fatigue there. And of course, the interesting one, introduced the task in the morning, performed it the following afternoon with a normal night of sleep, 60 to 70% of the group solved the problem. I mean, just spectacular data showing that, you know, our sleep is enhancing our ability to problem solve. Concentration, communication skills, decision-making skills, creativity, productivity, social connectivity are all impacted by lack of sleep. Then if we move on to sorry, Tracy.
No, go ahead, go ahead. Sorry.
So it's just like a stream of consciousness. If you think about physiology and health, then of course, increased chance of daytime sleepiness and microsleeps. In adults, of course, in the States, estimates vary from 100,000 to 300,000 people having crashes on the motorway system as a result of falling asleep at the wheel every year. Altered stress responses, so you tend to exaggerate stress responses when you're tired. Big impact upon the metabolic axis. Really fascinating and lovely work from Ed Van Couter's group in Chicago, taking healthy young males, they were university students, and one group were allowed to sleep only 4 hours a night, and the other as much as they, 9 hours or as much as they wanted. After just 5 days, the hunger hormone ghrelin was up by 27%. The satiation hormone leptin was down by 17%. And carbohydrate consumption after the 5 days had gone up by 35 to 40%. So big changes in metabolism. And lack of sleep, Ev Van Couter would argue, as part of the childhood obesity we see, this lack of sleep changing the metabolic drive for the consumption of carbohydrates in particular and promoting obesity, which I think is really, really interesting, and therefore type 2 diabetes. Depression and psychosis is something that we've done quite a lot of work on, and actually developed a model to think about the relationships between sleep disruption and circadian rhythm disruption and sleep. And I won't bore you with the model, but you can get it in the book. The bottom line was, we thought, okay, well, can we use sleep as a therapeutic target to reduce the severity of mental health issues? And we worked on young people with severe insomnia who were showing they were showing paranoia and hallucinatory experiences. And after several weeks of trying to improve sleep, we were able to improve sleep, and again we can talk about the methods. And what happened is that it halved the level of paranoia and hallucinatory experiences. And now psychiatry, and this was a study led by my colleague Dan Freeman in psychiatry in Oxford. And the exciting thing is that now psychiatry is really taking sleep seriously, and not thinking, oh, well, it's just sort of a byproduct of medication or whatever. It's now thought and being introduced as a therapeutic target. So those relationships between mental health and sleep are important. And in depression, for example, you actually see a change in the pattern of sleep prior to the onset of a depressive illness. And indeed, studies on teenagers have shown changes in the pattern of sleep prior to suicide attempts. So I think we can use this as an important metric. So there's some of the issues that have surfaced in terms of emotional, cognitive, and physiological responses. And there are, of course, others in adults, but we're focusing on adolescents here.
There's just been a question in the chat from Sue, and so I was actually just about to move on to this very question. What do we know about the impact of screens on teenagers, and specifically the blue light that screens emit, and how that impacts sleep at nighttime? Okay,
this is a very important topic, but there's also confusion and misinformation out there. So if we just unpack the biology to begin with, and it's work that we've done, we discovered this additional photoreceptor system within the eye, different from the visual cells, the rods and the cones. And it's these photosensitive retinal ganglion cells, which are maximally sensitive in the blue part of the spectrum. And so that was then used to say, well, hang on, you know, this could be a disaster for blue lights and all the rest of it. And in theory, yes, it could. But if you look at one of the key studies, which was to look at a Kindle, it's called a light emitting ebook, but it's actually they used the Kindle. They had it on maximum intensity, and people had to look at it from what was it, 6 o'clock to 10 o'clock in the evening. So 4 hours of continuous use on 5 consecutive nights. And that delayed sleep onset by 10 minutes. And as Mary Caskadon, who's done some brilliant work in this area on adolescent sleep, she said, well, it may well have been statistically significant, and it was only just after 5 days, but that's biologically meaningless. It'll be caught within the noise of, you know, what else is going on. Now, those blue light sensitive receptors can be sensitive to light in the evening, so in the order of, let's say, 50 to 100 lux, so sort of evening light levels. But to get any effect, you have to get long-term exposure, so you can get just a slightly significant effect, but you need 6.5 hours of light exposure. And the other recent data that's come out is that if you're getting normal exposure during the day to light, reasonable light levels, let's say 500 lux, which is quite low, it's the sort of thing you'd see in a brightly lit office, for example, but outside you get thousands of lux, then any subtle effects of light in the evening are completely abolished by bright light during the day.
How about the activity that's going on the devices, not so much the light itself beyond the light, but the kinds of activities, social media,
is the key
gaming.
point, Julian. Yeah, that is exactly the point. So I would certainly say don't use your smartphone and all the rest of it for at least 30 minutes before you go to sleep, because as you completely correctly point out, it's the alerting effect and the engagement that you get from interacting with these smartphones that is delaying sleep onset. So yeah, they are a problem. It's not so much the light, but it is the alerting effect they're having on the brain because of what you're doing.
Yeah, no, there's a few people asking about that, and we had also had a question asking about blue light glasses, which sounded like a sort of an idea for some. But what's your view?
It's very interesting. Again, I've sort of we've been looking at this. So I'm the specialist advisor for a House of Lords Select Committee study on the impact of light and noise pollution and on our biology. And in fact, the expert witnesses agreed with the studies I've looked at, which is that there's no evidence that these screen devices going from blue enriched to red enriched in the evening have any effect at all. And the same for blue blocking glasses. So it's the intensity that is very important. And I think it's really important to go back briefly to the biology, is that, okay, these receptors are maximally sensitive in the blue part of the spectrum, but it's a bell-shaped response. So if there's a lot of red light, that'll just be, as they can pick it up and they can see it. So it's the intensity of the light that is often the most important, rather than the wavelength itself. The other confounding factor is that we now know that the visual cells, the rods and the cones, can talk to those photosensitive, blue light sensitive ganglion cells, and we don't fully understand how. So the potential wavelength or color capture is very broad, and in fact some studies have suggested that short wavelength light picked up by a short wavelength cone in our eye might even inhibit these ganglion cells. So we don't have the full picture, but I think we should be less anxious than the media might like to suggest. And certainly if reading a few pages of a Kindle you find relaxing and as a helpful wind down before sleep, then you should do it. And I think this is so many people become anxious about their sleep, and the do's and don'ts, and the sort of the sergeant majors of sleep screaming of what they should and shouldn't do. And,
well, maybe we could talk about some of those things as sort of,
yeah,
what helpful and harmful. So you said earlier you're going to come back to napping, and actually someone has just raised that in the chat. So asking, can sleep in the day make up for going to sleep late at night? So she has a teenager that will tend to nap after school for a few hours, but then be keep themselves awake until the early hours.
this is a really important point. And so the consensus is that a 20-minute nap, but no longer, not too close to bedtime, so let's say lunchtime, can enhance cognitive performance in the second half of the day. The problem, though, as we found, and I think you, Julian, have alluded to, is that what many young people are doing is getting limited sleep at night, so shortened sleep at night. They're struggling through the school day, and not therefore able to engage fully in an educational experience, but then go home and will sleep for 2 and maybe even 3 hours. And what that does is push back the sleep pressure, meaning it's much more difficult to get to sleep that night, which means that you then can fall into a vicious cycle of shortened nighttime sleep, poor daytime performance, longer afternoon sleeps / naps. So you've got to be careful not to slide into that. So occasional naps, don't worry about it. It's
and this
fine,
is very prevalent. Our sort we're closely related to the Oxwell study. There are a number of colleagues working across Oxwell and brainwaves, and they report that 1 in 3 of years 7 to 13 children, years 7 to 13, have problems with sleepiness during the day.
And of course, it's because they're not getting the full block of sleep they need at night. And that's what's so important. That tells you alone, you've got to do something about your nighttime sleep. And I think if our young people knew of the value of sleep, then and it was part of the curriculum. We don't, it's extraordinary to me that a third of our biology is sleep biology, and we really don't provide much advice in most state sector schools about its importance and why it needs to be prioritized. And so it's still considered both by parents and young people as a sort of an indulgence or something that one can dispense with. We've got to prioritize it.
I think our participants, Tracy, have read your structure for
I'm starting to worry.
They're coming in on cue, aren't they? Absolutely. So there's the couple of other things that we wanted to talk about with help or hindrance. Could you say a little bit about melatonin? So there are some people who are being prescribed melatonin to help change their sleep-wake cycle.
Well, again, there's a lot of misinformation about melatonin. Melatonin is most emphatically not a sleep hormone. It certainly correlates with sleep because it tends to go up in the evening, stays high, peaks around about 4 o'clock in the morning, and then declines. But there are individuals, for example, on beta blockers, who produce very little melatonin and have a reasonably normal sleep. And there are other individuals who've lost their pineal, for example, and they can still sleep. So what it is a biological marker of the dark. It is a mild modulator of sleep. So the study which has shown its greatest efficacy, individuals took, I think it was something like 3 milligrams of melatonin, and it reduced the time it took to get to sleep by 20 to 30 minutes. And many studies have shown that it doesn't have any effect at all. So I would not say it has no effect on sleep. I think it does, but it's a very mild modulator. And so, would I recommend using it? Well, I suspect it's not particularly harmful, and we don't have a dose of melatonin that we know can do harm. I mean, you can give grams of the stuff, and it doesn't seem to cause any major problems as far as we can tell. It's not to say that there aren't necessarily problems. It's probably having a placebo effect at some level, but it's a mild modulator, and I would far rather people used behavioral changes than reverted to any sort of drug.
So in terms of, you touched on it earlier in terms of the school start times.
Yeah.
Is that an effective thing that we should be looking at too?
Well, again, I think this is a really interesting area. So what the UK has been influenced by are the studies from the United States, very good studies from the States and in Germany, showing that an earlier start time can reduce depression, a later start time, I do apologize, a later start time can reduce self-harm, reduce depression, increase educational performance. But we've got to look at the detail, because what the California school system was saying is no class should start before 8:30 in the morning. Many studies, many classes are starting even 7 a.m. in the States, and again very early in Germany. And where you've shifted that to a later start time, you've improved cognition, mood, and all the rest of it. In the UK, of course, most of the state sector schools start at 10 to 9 or 9 o'clock. I know we were talking earlier that some are kicking in at 8:30. But I think changing the start time is complicated. And my first line would be to introduce educational materials. So the team here in Oxford developed with teachers 8 30-minute sessions about the importance of sleep, circadian rhythms, and what you might want to do to improve your sleep and prioritize sleep. And we looked at the whole group and we measured rest activity cycles and took questionnaires, and we showed that about 20% of the group would have had 20-25% clinical levels of insomnia prior to the educational intervention, and we were able to move that 20% and improve their sleep very significantly. So I would propose that we introduce serious sleep education taught by teachers in the school environment, and also we produced a small booklet, a small pamphlet rather, for parents to understand and prioritize sleep. One thing that we discovered on that study, which still terrifies me, is that we asked the early adolescents, do you share your bedroom with anybody else as part of the collection? What we didn't ask is, do you have a bed? And we discovered that in lower socioeconomic groups, many kids don't have a bed. They're sleeping on the family sofa while the family are watching telly. They're getting terrible sleep, so they can't embrace their educational opportunities. And so, you're already sort of getting a positive feedback loop whereby they're being marginalized because of their educational opportunities. And that's made worse because they just aren't getting the sleep that they need at night. And we've also talked to some of our American colleagues, and they did a study in poor families where they provided decent pillows and actually were able to show improved sleep with that. So it's all, we've got to think actually about not just the sort of things that we're familiar with, but those lower socioeconomic groups where sleep is really being marginalized.
I've started taking my favorite pillow away with me. I thought that was just a sign of age, eccentricity, and general grumpiness. But I'm now going to quote you as supporting me in that.
Julian, it may be in your case, but I understand.
I do it too.
Yeah, I mean, but it's interesting. I think we Brits, I don't know if it's unique to the Brits, we're a bit mean about bedding. We don't sort of think, embrace, I think we resent paying for decent pillows and duvets and mattresses and things, and whether we grind these mattresses into the dust after maybe think about after 30 years changing it. But actually it's a third of our lives. We need to invest in something that works for us.
Very good point. We've got a few minutes left, Russell. What would be your sort of top tips or strategies if you were talking to a teenager now, to try and suggest to them about ways that they could manage their sleep habits better and get the sleep
that they are needed, but probably aren't getting because they're going to bed so late?
Well, I would certainly, and Julian made this point, is make them aware of their sleep needs, and use those bullet points and sort of take that really seriously, and also explain how important what sleep provides. It's not just when we're physically inactive. We may be physically inactive, but our brain is doing absolutely essential things, affecting our sense of humor, our ability to function during the day. A decent night of sleep defines how we function during the day. So really emphasizing the importance of sleep itself, the biology, and that we're very different, and we need to define the sleep patterns. And then some tips, so get that morning light. Don't oversleep at the weekend, because also you don't catch up. Some very interesting studies have said that if you're really sleep deprived during the week, oversleeping at the weekend isn't sufficient to fully repay that sleep debt. We've talked about napping, but I would also say, and I think adolescents, teenagers have a very difficult time. They are bombarded with so many stressful and anxiety-making situations, and many people don't have a sleep issue. It's an anxiety or a stress issue. So do something that allows you to de-stress at the end of the day, whatever that may be. It may be listening to your favorite music, or a few pages of Jane Austen. Probably not, but that sort of thing. Don't slide into the trap of using sedatives such as alcohol and antihistamines, and I think a lot of young people are doing that. And then about the bedroom, and we kind of touched on this, make sure it's not too warm, because part of going to sleep is actually a loss in core body temperature. And so that's why, yes, absolutely exercise, but try not to make it too close to bedtime, because that raises core body temperature and makes it more difficult to get off to sleep. We've talked about blackout curtains, but also try and make the bedroom, and I know this is difficult, a haven for sleep. Since lockdown, many bedrooms have become offices, but if you possibly can, get rid of the computers, the TVs, all of those things that would prevent you from sleeping. One other thing I'd really like to stress is don't take sleep apps seriously. They can be a bit of fun. They can tell you roughly when you went to sleep and roughly when you woke up, and in that sense they can be useful, because in the same way, if you want to lose weight, you change your eating behavior, you weigh yourself in the morning, you see a change in weight, and that reinforces your change behavior. But when they start saying, oh, you had a good night's sleep, or you didn't get enough REM sleep, or you need more slow wave sleep, they simply aren't accurate enough to do that. And again, many people get anxious about these sorts of bits of information.
Can I ask one very specific thing? A couple of people have asked questions about teenagers who have periods of wakefulness during the night. In other words, they go to sleep, but then they wake up in the night.
This is so important. Yeah, absolutely. And of course, this is not just a teenage problem, but it occurs throughout the lifespan. And some really important data, first of all, by a social scientist, Roger Eckert. He looked at the records of sleep in the pre-industrial societies and showed that it was what's called biphasic, which means you would go to sleep, you'd wake up, and then you go back to sleep again. And you can have biphasic sleep, or indeed polyphasic sleep, and it goes, lots of records documenting this. That then stimulated Tom Weir to do the experiments, and he put individuals and they had opportunity to have an expanded sleep, so I think the experiment was 12 hours of light, 12 hours of dark, and found that again our sleep became biphasic and polyphasic. So what's happening is, if the sleep is so horrendously compressed, it means we don't experience that biphasic polyphasic. But if we do, we shouldn't worry about it. It's basically something that's all mammals have this sort of fragmented nighttime sleep pattern, and the key thing is to stay calm, stay relaxed, keep the lights low. You don't think, oh my God, that's it, I must have start drinking coffee and doing emails. Just you may want to leave the bed space, but just stay calm. The other thing related to this is clock watching, which is if you wake up and you've got an illuminated clock next to the bed, you see, oh my God, I've only got 2 hours before the alarm goes off. That then, makes people anxious and therefore more difficult to get to sleep. So what I recommend is actually you cover. It's when the alarm goes off that's important, not how long you've got before it goes off. So cover the screen. So don't get anxious about waking up in the middle of the night. It's perfectly natural. And if you stay calm, stay relaxed, keep the lights low, you will almost always fall back to sleep.
Fantastic. Well, it's 5 o'clock, so I know we could talk for a lot longer, and I'm sorry to everybody who has put so many questions into the chat. I think we could have been here all evening if we'd have wanted to. I think there's a point, Russell, that you've mentioned a lot of studies in your today, and what would be great if we could just go back and maybe find the references to those.
Yeah.
So I'll come back to you on that, and hopefully
Absolutely.
we can get those out to everybody.
And most of the
teen
references are in Lifetime.
Yeah,
Yes.
and the teen sleep lessons as well. A few people are asking practice for those, so maybe we can talk to you about how we can make those available to brainwaves people.
Absolutely, and I'm very happy to come back and do another Q&A if we really, if there are lots of issues that we haven't addressed. So happy to.
Fabulous.
Yeah.
So just as a lead on from that, we do have the free brainwaves lessons available at the moment that have been developed to support student mental health. I think somebody has already posted that website in the chat, but just in case you haven't found it, it's education.brainwaves.org. Sorry, it's education.brainwaveshub.org. And at the moment, we've got 5 lessons for Key Stage 5 students on sleep, the teenage brain, managing stress, talking about mental health, and boosting your mood. So they're all free with accompanying lesson support and teacher notes and teacher guidance if you want to go and download those. So we've got Key Stage 3 lessons coming next term, and also Key Stage 4 lessons early next year. So do keep a lookout for those. Okay, so thank you everybody to all the messages and questions. Apologies again that we weren't able to get through those today, but I would like to conclude the webinar by offering my sincere thanks to Russell for his time today. It's been a wonderful opportunity to listen to you and to learn from your knowledge and expertise. So thank you very much. We're very grateful.
Really great delight. It's so important that you're getting the message out. I'm so pleased.
Absolutely. Thank you, Julian. It's great to see you again. And thank you to everybody for attending today. There's always lots of demands on your time. So if we can help spread the word about sleep education, then that's a wonderful thing to do. Yeah. Take care, everybody. We hope to see you in another Brainwaves webinar very soon. Have a good afternoon.
Thanks again. Bye-bye. Bye.